Okay. So preparation.
I only had questions about the homework, just a couple of things about the homework.
Yeah, I just wanted to see part 2. It shows to compare.
Oh, the 2.
Yeah, to 3 other. I just wanted to see what you guys got.
So
Yeah.
my mean was 43,520.
Oh wow, yours was low.
Okay, mine was 45,640.
Oh wow, yours was really close. Mine was 48,040.
I'm still getting mine up here. Okay, so part 2.
Yep.
What was the mean?
Yeah, what was the mean that you got?
46.8.
Okay, so yeah, everybody's was within that.
That little bit.
So that's like the central limit theorem, correct?
Yup.
Okay, now did anybody else notice that on number 8, they didn't actually give you numbers?
What do you mean?
Like, it says like the scores of the GMAT are normally distributed with a mean of, and then there's like no number.
Oh, I had
And a
numbers.
standard deviation
Yeah, I had
of.
numbers.
I had
I
numbers.
don't have numbers.
Who did
They said mu equals 529.
Okay.
Sigma equals 113.
Okay, so the mean was 113. Okay. Yeah, that was a lot. That would be a lot easier to solve.
Yeah. You couldn't figure it out with all the numbers?
Yeah. And even my answers on my answer key were blank.
What?
That's weird.
Because you have to scroll through and then go to the second part of the key.
That's weird.
I mean, I printed them out and they're just blank.
Go lay down. Go lay down.
That's weird.
Yeah.
That is bizarre.
Yeah, because I printed mine, but they showed up.
Yeah, mine just like, it literally just says distributed with a mean of, and then it just keeps going. Like there's hardly even any space for a number. It just.
So weird. Weird.
All right.
So yeah, the mean was 529. The standard deviation was 113. And did you get the N of 10? Did that show up?
No.
Yeah.
No numbers in the problem.
Oh, that's so weird.
Okay.
Like even on the stuff like the question, like above that?
No question. There's no numbers in the question.
Oh,
I
weird.
thought I was kind of going crazy, but there's no numbers.
Well, if that happens again, feel free to text and be like, "Hey, do you guys have numbers in your question?" Or like, "You're not bugging me if you text."
Then
Okay.
we'll mess with you and be like, "Oh, you don't need numbers to figure it out." All right. So, did anyone have any more questions on the prep?
No. I think I get it. I think I'm going to go back through. I realized I didn't watch the videos and stuff. I think I'm just going to study it a little bit more later, but I get the general idea.
So how did you guys randomly select your, I had my 4-year-old. I said point one, okay, point in another one. I'm like, that's pretty random.
That's pretty random.
I just randomly went through and went like 1, 2, 3, 4, 5.
I did that random.org thing. I thought that was kind of funny.
I tried doing that, but I didn't quite get it.
I thought it sounded a little.
You get the number of the square that you need to, so then you, like I got 22, so I went to 22 and used that number, and I got number 2 and I went to number 2 and used that.
Oh, I get it now. Okay.
Yeah, it took me a minute 'cause I was like, wait a minute, I was just using these numbers? That doesn't make sense.
Yeah, I was trying to make it complicated. Okay.
I know, I did that at first, but.
Okay.
Okay.
So homework. Any questions on the homework?
I have a question.
Okay.
So 13, let's see, 12 and 13.
Okay.
So a lot of times I just get confused with the lingo. Like, what the heck are we trying to find? What, I mean, I get the, you know, where you take the standard deviation, you take the square root of what the sample mean? I don't even know. So I just know like this particular number, you do this stuff with it, but I don't actually know exactly
So
what exactly that number is. So on number 11, you know, I did the equation and I get the right answer. It's 2.921.
Yeah, see, I didn't get the right answer on that. I don't know if I did that right. You take the square root of 266, right?
no.
No.
So the equation, which is really the only thing I understand how to do, is you take the standard deviation
Which was 16.
and you divide that by the square root of the sample.
Yeah, which was 266, right?
No,
Oh.
That's the mean.
Oh, that's the mean. Oh, wrong 30. Okay, there's my problem. My bad.
See, I have to go and highlight when I read the question. I highlight like, okay, mean 266, standard deviation 16, and then I write them down so that,
Yeah, it kind of helps for me to write like mean equals standard deviation equals sample equals blah. Okay, so is that number the X with the bar over it?
that's the average mean.
Yeah, that's the average mean.
No, wait.
The X with the bar, what is that? Like what is that?
That's the sample mean. X bar is the sample mean, just the mean of the sample.
Okay.
And then
As far
we're
as
getting the
It's called X bar.
X bar. Okay. So what is the number that we're getting from that equation? The standard deviation divided by the square root of the sample.
Isn't that the mean of distribution means?
No, that's the standard deviation of the distribution of the sample mean. So that's the standard deviation that you're finding.
Okay. So given that, when it says, is the mean of the distribution of means greater than, equal to, or less than the parent population mean, where are you finding the mean of the distribution of the means? Where is that number?
Well, so this is that assumption that you make if n is greater than or equal to 30. So the random sample in this case is 30. You assume that it's equal to.
So that's just saying it's a normal distribution because it's
so then you're saying the mean of the distributions would be equal to the mean of the population.
Okay. That's what I was just confused about because I just get lost in the lingo. They're saying the mean of the distribution of means.
Right.
I know that's representing some number, but I just don't know which number. So
Just always equal to. In a case like that, it's just always equal to. The mean of the means is equal to the mean.
Yeah, as long as you've got a sample size of 30 or more.
okay.
It's just equal to. No matter what it is, you're just like, yes, it's equal because it fits this criteria. So then the mean of the means is going to be equal to the mean.
Okay.
If the sample size is high enough. Does that make sense?
So if it was, well, let's say it was less than, less than 30, then it would be less than?
Good question.
I mean, at that point, you couldn't be sure that it would be a little bit further off. We wouldn't know for sure if it was less than but I mean, it's not as probable that it would be equal to it.
Right, so it would be less than or greater than. I just don't know. Okay.
Could coincidentally be equal is a coincidence, but you wouldn't know unless you calculated it if it was a sample size less than, right?
Yeah.
Right? Does everyone agree with that?
That's what I think.
So when you look at 11, the standard deviation of the sample means is much smaller. It's 2.921 versus this standard deviation of the mean, because the sample mean standard deviation was 16, right?
Yeah, so I think that standard deviation is what we were calculating before, where you've got the whole data set, and so you've got some outliers, and so that's why that standard deviation is so much bigger. Whereas when you're taking the deviation of the sample means, they're all the averages, so the standard deviation shouldn't be too far off.
Okay.
The standard deviation would be the larger.
Closer.
Or-
When you take the standard deviation of the sample means than if you took the standard deviation of just the general population.
Okay.
Does that make sense?
Yeah.
So it would be the standard
So
deviation of a sample.
is that why 13 is less than?
Well, yeah, I mean, because you even calculated it in 11, so you see that it's less than.
So
But it would
what
always
I'm
be
comparing
less than.
though, what I'm comparing is the standard deviation in the question of 16, and I'm comparing that to 2.921.
Yes.
But it'll always be less than.
It should be, yes.
I mean, because you're getting rid of all the outliers, because
Because you're averaging
you've
it.
got
Yeah.
sample mean, a sample mean, a sample mean, a sample mean. So now you've got all these sample means. So you
Yeah,
don't
the
have all these outliers. You just have a whole bunch of sample.
I mean, you know, there's always an exception to the rule. Like, what if, like, every sample you chose was an outlier? You know, then your mean would be a little bit different. But I mean, I think for the most part, the standard deviation of the sample means should be smaller than the standard deviation of the population.
But would the sample be a certain number in each sample? So you couldn't just get an outlier because each sample would be several.
Well, do you know what I'm saying? Like, if you did like a sample mean, one of your sample means was like out of the whole data set between 1 and 100, you had like an outlier of 1 and then 100, and everything else was around 50, and you were taking like all of the outliers and got that mean. So I mean, if you, it all depends. So I mean, it's all random.
So it'd be unlikely, but
Yeah, very unlikely. I'm just saying. So for the most part, it should be less than.
okay. Generally speaking, it will always be less than if you're taking the standard deviation of the sampling distributions.
Of the means,
So,
yeah.
yeah.
Okay.
Does that make sense? I'm going to plug it one more time. That
No,
AP
you did, I got
Stats puts this in such clear language for me. That's with the making the distinction between the sampling distributions and the distribution of the sample. I mean, he's like my saving grace on this.
Which guy?
AP Stats guy on YouTube. He makes it so clear. He dumbs it down and makes it, yeah. So anyway, okay.
Well, that makes a lot more sense to me. I need to associate numbers in the problem with the English that they're using to describe those numbers, you know?
Yeah,
So
my heart is converting word problems to numbers, so I'm right there with you.
okay, well, that makes sense to me. Those are the only questions I had. Does anyone else have any questions?
I'm good.
Yeah, I missed 13 too the first time. So then I had to go back and rethink it. So you're not alone on that.
Okay.
Yeah, I had to go back and read the central limit theorem and the law of large numbers just because I was like, wait, I thought I got it. No, I don't.
I know, I thought I did too until I had to pick them out on the multiple choice. And then I'm like, what? They all, yeah. And there's so many different ways they describe it. Because I'm like, well,
Right. It kind of boiled down to shape and distribution.
mhm. Shape and spread is the way,
Yeah, shape and spread of the distribution.
Yeah.
Mm-hmm.
So
yeah.
okay.
I feel like the one is more numbers and the other one is more of a representation.
Meaning the theorem is a representation?
Yeah.
The shape. And the law of large numbers has to do
Pretty
with
much saying that the mean is the mean, as long as you've got enough sample.
Well, and it gets smaller. The standard deviation gets smaller
Yep.
with the law
Yes.
of large numbers.
Okay, are we ready for the group quiz?
Yeah, I think so. Larina?
Yeah.
Okay. Okay, everybody in it?
Yeah.
Okay. So questions 1 and 2, did you go to the group meeting? Did you prep? Number 3, when you're taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed? It would be skewed right, correct?
Right,
Yes.
because it's less than 30.
Okay. Okay, so if it's n equals 100, then it would be normal.
Hang on 1 sec. I'm not actually there.
Okay, sorry.
Internet's being super slow. Just a minute.
Yeah, it took, mine was kind of hanging up too.
Group. Lesson 6 is what we're on, right?
Yep.
Okay, start quiz. Okay. Okay, so 3, I have to go over that. When you're taking a sample size of n equals 5, what is the shape of the distribution of means when the parent population is skewed right? You guys said skewed right, right? Right skewed? Skewed right?
Mhm.
Okay. Taking a sample size. What is the shape of the distribution? Normal on 4, right?
Yep.
Okay. Are we on 5?
Yep, so number 5, yeah, so the sample size is n equals 5, and it's normally distributed, so it would be normal.
Okay. Okay.
Okay, and the other one, n equals 100, so it's still normal.
You're so fast. I have to read like every word. What is the shape of the distribution?
Well, I'm just assuming just because the other 2 were
Okay.
normally distributed. Okay, does everybody agree 5 and 6 normal?
Yeah, I do. Okay, when would the
7 normally distributed. Data are drawn from a population that is normally distributed. That's true.
The top, yeah, the first one's true.
Number 2 is true. Number 3 is not.
true?
And number 4 is true.
True, right? Okay, so
Yes.
everything but C.
Yep.
Yeah.
There you go.
Okay.
Okay.
That last one kind of tricks you a little bit.
Mm-hmm.
Yeah.
Okay, so which of the following gives the best explanation of the central limit theorem?
If the sample size is large, the sample mean X bar will be close to the population.
That is the
Mean.
law of large numbers.
That's
Oh, and I get
law of
big
large numbers.
So it's actually the one under it, right? If the sample size is large, the
There we
shape of the distribution will be approximately normal, correct?
Yeah.
That's what I
Okay.
got. Because the one above it is the law of large numbers. Sample mean.
Yes.
Wait. If the parent population is normally distributed, then the sample will follow a normal distribution.
Yes.
I thought it was the last one. If the sample size is large, the shape of the distribution of sample means will be approximately normal.
Yeah, because right here on the homework it says the correct answer was the central limit theorem describes what happens to the shape of the distribution of sample means when the sample size is large.
So it's the 4th one, right? D?
I think the
Yeah.
4th one too, but the A,
It's not true because it's not talking about shape. It's talking about the
It's
distribution.
tricking you.
oh, it's
Yeah.
tricking me. All right. All
So
right.
the X bar is associated with the law of large numbers.
And
Yeah.
whenever it talks
Okay,
about shape, that is the theorem.
Yes.
The following theorem.
Okay. Where did my quiz go? Oh, there it is. Okay. Let X be a random variable. Population 10 and a population. 6.
Okay, so the mean would be 10.
Yes, I agree.
Okay, so now we gotta do some math.
Standard deviation of the standard deviation of the
Is that
distribution.
gonna be 1?
Yeah.
You guys are fast. I haven't even written it out yet.
Sorry.
Well,
So
only because the square root of
over
36
the square root of
I got 1.
sigma.
So 10, you do sigma divided by the square root of 36, which is 6. So 6 divided by 6 is 1.
Yeah, I'm there. All right, so yeah, 1. That's 1.
Like I get
Yeah.
it in my head, but I would still write it out, Heather. Like I still have to do it all. Just
do.
make
I just,
I probably should.
I'm a-
If I didn't have Laura going, yeah, that's right, then I would second guessing myself.
regardless of the distribution of population, if the sample size is large, what would the shape be? Normal, right?
Oh, wait a minute. Did we do 10? We skipped 10.
10 is
No,
1.
10 was the number 1. 9 was 10. Does that make sense? Haha.
Okay, no. Well, question 9 was
10.
The
10.
answer.
Oh, how did
The mean of the means in a large sample size is the same as the population mean is the same as the
oh.
Yeah. So
I
that's the law of large
totally
numbers
missed
right
that.
there. That's number 9. Number 9 is the law of large numbers. Number 10, you're doing the calculation for the standard deviation, which would be 1.
Oh, I totally missed even doing that one. Okay, so now number 11, regardless of the population.
normal. It's like they really want us to understand
Yep.
that. We may see that again.
And that was the law of large numbers.
No.
That's the limit
That's the
theorem.
central limit theorem.
Yeah.
Okay, see, I'm all right.
Talking about this shape. See the shape?
Yeah. Yeah.
What theorem will justify your response? Oh, okay. Central limit theorem. Okay.
Yeah.
100%.
Dun, da, 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 da.
Okay. Any other questions?
No, I'm good.
I have a question. Where did you guys go? I can't see.
Huh?
It's okay. I can hear you all. It doesn't matter. I'm just
Oh,
being ridiculous.
okay.
Okay.
All right. So good to end the chat, and then Lorena can make her appointment.
Yes, thank you.
And then on Thursday, just our regular time, noon.
Sounds great for me.
Okay. See you guys on Thursday. If you guys can't see any numbers, just give us a text.
Yeah.
Hey. Take care, you guys. Have a good week.
Thank you.
Bye.
Bye.
Bye.